Okay, my name is Michael Moore. I'm a executive director at Ernst & Young. I'm responsible for our relationship with Neo4j. We've been working with Neo4j closely now for about 3 years. And I lead our national practice in knowledge graphs and AI. And I'm a huge proponent of graph-based technology. I think this is the wave of the future. I bet that probably 50% of all SQL workloads are going to move to graphs in the next 10 years. And so you guys are absolutely at the right event. This is a real conversation that's happening. If your organizations are thinking about this, this is a great place to start. And this isn't like a fad or a flash in the pan. Graphs are here to stay. There's lots of investment in them. There's a real market. It's a competitive market. Neo4j is the most established player in this market, and we're pleased to be able to work with them closely. So today what I'm going to talk about is how you begin the graph conversation at your company. And I want to introduce this notion with a couple of things that are probably, you've probably been observing these in the background. But essentially, we're in the middle of a paradigm shift between going from kind of a traditional single data model, single vendor approach for management of data, where you take your data and you transform it so it fits into a SQL-style database, whether that's Oracle, Teradata, SQL Server. Now, in the last 10 years, we've seen the emergence of fit-for-purpose databases, where the design of the database is actually designed around the shape of your data, and that's why we have this proliferation of NoSQL databases, where there's document stores, there's key value stores, columnar databases, time series databases, and in the new paradigm, the idea is you pick the data platform that fits the shape of your data. And if your data has a lot of relationships in it, and the relationships are the subject of interest, then you would pick a graph database. And then all of these databases are now at this stage very interoperable. They're part of modern data management stacks, and then they're typically surrounded by a bunch of ancillary services to bring those stacks to life. So why are graphs a story? So graphs have been around for a long time. But what's making graphs interesting is that the hardware that's available now allows you to literally take an entire data warehouse and put it on a single server. And I live in Seattle, which is the middle of cloud country, and so I get to see these wars going back and forth. And so a few years ago, AWS made a big splash when they started releasing their X1 line of virtual machines with 4 terabytes of memory. That's a lot of memory, and everyone said, wow, that's really cool. And so then, of course, Microsoft, who's 13 miles away, said, you know what, we're going to do that too. And so then they released the next year 12 terabyte machines. And Amazon said, well, we'll go up to the next level and we'll meet that. And then now if you go out onto Azure, you'll see some fine print where if you pick up the phone and talk to your friendly Azure representative, you can actually get a 24 terabyte VM. So think about that for a second. 24 terabytes is a huge amount of RAM. And in fact, even if that's not enough, you can go out and talk to IBM, and they will gladly sell you a piece of hardware where you can have up to 500 terabytes of RAM. So I think that in the next 5-10 years, we're going to literally see petabyte scale VMs. And so when you have that much memory at your disposal, why not put your data into a graph where you can materialize all the relationships between your data points and have a whole fabric that you can query instantly, right? And so scale up so big hardware is kind of the story behind a lot of graph popularity. There's a website out there called dbengines.com. And dbengines.com basically tracks the developer conversation around new technologies. And so they look at things like, Stack Overflow posts. They look at pull requests on GitHub and a bunch of other things. And one of the really consistent stories is that as far as the data development community is concerned, graphs are hot. And the popularity of graph continues to be the fastest increasing area of interest among developers. So what is a graph database? So a graph database derives its structure and what it does from the basics of a graph. And so for those of you who have never seen a graph, you've probably actually written many of them. So anytime you're holding a dry erase marker and you're standing in front of a whiteboard and you begin to draw circles and bubbles to explain a business process, you're building a graph. And so what a graph really is it's a visual representation of how data is connected. And so, and it's typical to describe business processes in terms of a graph. And so this is a very, basic example. So what's, e-commerce? We send email to people. We want them to go to our website and buy our product that's sold on the website. If I was to graph that business process, it would look like something on the left. And so I'd have a bunch of emails. I'd be sending those to people. I want those people to visit my website. And I want them to do something on the website, like purchase a product that's in stock on that website. And so what's a graph database? So a graph database is a database that's optimized for the storage, querying, and management of data in graph structure. And so in a graph database, you would have millions of records, potentially being your emails, all of your outbound emails. Each one of those emails that have been sent to an individual person, so you might have hundreds of thousands of people, there would be a relationship, a hard-coded relationship represented as a data point that's stored on disk in memory, and because it's a real object in the database, you can actually put data on that relationship. Those relationships will typically be typed in the property graph model, which means that they have a name, and so then they become part of the semantics of the graph. You can also see that they have things like directionality. So I can say that an email was sent to a person, and that makes sense. That's how it works in the real world. And so graphs have good semantic fidelity to business processes, which is one of the reasons why they're very easy to be able to have a very good discussion with your business stakeholders. Do I understand your business? Have I represented it properly? Have I built a structure that we can query and get good answers out of? Now, the query language for Neo4j is called Cypher. And Cypher is a declarative language like SQL. But instead of having to declare what tables I want to join with what other tables and having knowledge of the keys that I need to drive those joins, in a graph database query, what you're actually doing is you're declaring a traversal path through the graph. And so here's a little query here. And you can see that we're saying, find all the emails that were sent to this person named Steve. And so there's a single Steve record, and that record is part of the person's set of nodes. And we're going to find all the emails that are connected to Steve. And we're also going to require that Steve has visited the website, and he's purchased something that's been sold on the website. And if that path is true, I'll receive back a row of data from the database. And in fact, I'll receive back a row of data from the graph database in every instance where that path is true, on all possible traversals that fit this pattern. And that's how you query a graph database. Okay, so one of the first things you want to do when thinking about your graph projects is you got to get your graph goggles on. And so does everyone see the graph here? Right? Anything that's a network is a graph. How about here? Does anyone see the graph? Anything that has complex hierarchy is a graph. Anyone see the graph here? Anything that has flows from point A to point B, whether it's supply chain or materials, is a graph. Does anyone see the graph here? Any type of transactions involving people and objects, like say products or bank accounts, right, is a graph. Okay, and so you want to think about your, getting your graph goggles on, thinking about data in a newer way. And of course, the other thing that I want to point out is that any SQL database is actually a graph. And the very first thing that you do when you design a warehouse is you sit down and you build the concept diagram for your data warehouse. And that is a graph. And I believe that if Larry Ellison had as much computing power back in 1970 or 80 when he was putting together the first Oracle database, he probably would have done something that would look a lot like Neo4j. But he didn't. And so everything that you see in SQL is basically a workaround designed to handle limited compute and limited memory. That's why the users pay the cost of running a query. What do I mean by that? So when you run a query in SQL, the end user is the one who's waiting for those joins to be computed in memory. Every single time, every single query. In a graph database, those joins are computed at write time. And so the trade-off there is that a graph is a little slower to write to, but it's way faster to read from. And you usually have far more reads than you do writes. Okay? All right, so graph use cases, lots of use cases. Most of our customers start with a customer 360 view or an asset 360 view. And usually, the reason for that is that most of the data that goes into these kinds of views is coming from a variety of legacy systems. And maybe they've landed the data in a data lake, but they're still having trouble unifying the data because there's so many disparate entities. And so Customer 360 is a good place to start thinking about your graph problem, but there's many other use cases. Oftentimes, the Customer 360 work will quickly turn into some kind of a recommendation engine or a detection engine because pattern recognition is very easy to do in graphs. And so, common patterns become recommendations. Rare patterns are usually some evidence of something going awry. So maybe it's a fraud ring or some point of failure in a network system, things like that. Generally speaking, the way you want to think about your graph is we feel that they're best deployed on top of data lakes. This is a very common thread through most of our graph engagements. And usually what's happening is there'll be some team, and you can look at those buckets across the top there, that is dissatisfied with the level of reporting and analytics that they're getting out of the data lake, and they want to do something that's more powerful. And so we might start, maybe it's over on the marketing side, or we're starting on the sales side, or somewhere in between in operations. But generally speaking, there's some need. It's either an application, it's better BI, or it's empowering the data science team to be able to look at a lot more data that's sitting in the data lake. And then this gives you kind of a nice stack. So conceptually, what you're really doing is you're saying, we're going to pull our important data, not all of the data that's in the lake, but the important data that's in the lake up into the graph. We're going to use the graph as a vehicle for creating a common business language. We're going to use the graph to impose some standards around taxonomy and concordance. And then we're going to hook our applications up to that level or that layer, that connected layer of data. And that's what's going to drive our next generation applications in BI and advanced analytics. And so this is, and then I'll also point out, once you handle one or two use cases, it's very common for the business to come back to you and say, all right, now that you've solved this use case, can you bring in this other data set? And with this kind of a general approach, it's actually very easy to do. Okay. So let's talk about this roadmap for enterprise graph strategy. And so the scenario here is, one of you in this room has decided, what, I want to bring graphs into my business. How do I do it? How do I win at this conversation? How do I move the business? And so generally speaking, you want to begin with identifying your graphy problem. You'll build a local host just on your laptop, a small POC. You'll move that POC into a cloud pilot. And then you'll eventually graduate that into a production build. And like most data work, you need to understand your use cases, so you gather your stakeholder input. You'll spend some time designing your graph. And the thing that I want to point out is that when you do graph design, it's a very iterative process. Graphs are very easy to manipulate. They're easy to change the design and schemas involved in the graph. And so you don't have to be right the very first time. It's not like building a data warehouse. So you can come in with a theory of how the data should be connected, and if the query loads or your business stakeholder input tells you something different, it's actually easy to change the graph and adapt it very flexibly. And so even in bigger graphs, we always revisit the design of the graph. Data work is inescapable. You always have to work on data. And one of the things that we often see when we do these kind of unification projects across multiple data sources that are in a data lake is that it's in the graph where you actually begin to detect some of the real issues with data, because you're actually slamming data together that has maybe never been joined together. And then finally, there's a lot of great ways of interacting with the graph. You've seen lots of visualizations and things like that. Generally speaking, most graph stacks will have some kind of a middleware layer that is supporting the APIs that are talking to your applications or your BI stack. And then from there on, it proceeds like any other IT project. You don't need a large team to build a graph. Most of the teams that we bring in or our clients stand up are generally around 4 to 5 people. And usually there's somebody who's a champion. And so I'm hoping one of you in this room will become a champion for your company. But you don't need a huge team. And so typically you'd have a graph architect. You might have a data engineer who understands the environment, maybe a developer of some sort, depending on what use case you want to demonstrate. And then maybe some data scientists or maybe some report developers. So small agile team works quite well. Okay, so what is a graphy problem? So this is just a hit list. I'll go through it super quickly. So anything requiring a lot of entities, anything requiring recursion, where I'm joining the same data to itself, anything where I've got complex hierarchy, scenarios where it's the relationships that are important, not as important as maybe the individual records. Anything that requires very fast query results. So Neo4j as an in-memory graph is super performant. You should expect queries to be coming back, particularly like singleton queries where I'm passing in a customer ID and I want to interrogate all the nodes around that customer. 200 milliseconds, 100 milliseconds or faster. And then if you can't figure one out on your own, go talk to your business. Don't be shy. Anybody who is running some form of business in your company will have a very long backlog of analytical questions that they've never been able to ask and answer of the data that's under management. You can go to this great website called neo4j.com/download. And you can actually download Neo4j onto your laptop. And the version of Neo4j that you're downloading is the enterprise version. And it's got a really nice desktop application wrapper around it that lets you stand up multiple small databases on your laptop. And so the first thing I would do is encourage you to go there, download it. And then if you use, there's a really nice package of utilities called APOC. And when you download the desktop, there's a button there where you can install APOC with a single click. And then there's a little configuration page. And if you type in these configurations here, you can actually load data using APOC very easily. And so you can begin with some CSV files. There's a couple of ways you can do it. There's a Neo4j procedure there called load CSV. And you can see I've got some local file path, and I'm dumping my CSV files into my graph. Or I can use the APOC one, and I can load from a URL. And that URL can be a file path, or it can be a remote web location. And any reasonable laptop, like an 8 or 16 gig machine, you can build a graph that has millions of nodes in it. Graphs are very, very compact. And so your local host demo can actually be a very powerful demo in terms of the amount of data that you can push into it. Okay? Some of the things that you might want to think about when you do your POC graph is, just start with a handful of data sources. Don't attempt to boil the ocean. Use common sense business naming for all your graph components so that when you show your graph to your business, they immediately recognize what it is you're trying to represent, and they can give you the kind of feedback. You can handle things like recursion in your graph design. So there's a little query there, an employee reports to an employee, right? That's a totally legitimate way of designing a graph, right? And so you can handle things like complex recursion and things like that. At this stage, you don't have to get too hung up on the design of your graph. You might think about, well, should this be a property? Should this be a node? Those kinds of things you can deal with later. But at this stage, you're just trying to get, is there a data domain, a set of business problems that I can put some data together in a graph and run a new set of queries that our business has never seen be executed before. If you want to show your graph to other people, there's a great website It's HTTP APC Jones. You might have to put a www in front of that to get it to work, that URL. But there you can basically create schematics of your design. And there's a couple of other ways to do that. But the main thing to do is get your graph together on your laptop, do it yourself, get comfortable with the Neo4j platform, and then write some queries against it, simple queries that can test your graph design. And then when you get to that point, then you can have a really nice conversation with your business stakeholders, and they can probably suggest additional questions for you. So I'll give you some examples of graph schemas to get you thinking. So we talked a little bit about Customer 360. So one of the reasons why Customer 360 is an interesting problem is because most businesses have customers. And the more you know about your customer, the better off you are. Customer data has many different shapes and sources. And typically, like this is a B2C example. I have got my customer node up there at the top, so that I might have hundreds or millions of customers. And then related to every one of those individual customers, I might have data about their demographics and how they've been segmented. I might have a whole variety of marketing touches coming across different channels. They have probably executed transactions if they're a customer. So that means that they have a product history. They have individual orders. They've paid for those orders with different forms of tender. They may have come through either my physical stores or my e-commerce stores, or maybe through a partner. And then I have a whole bunch of identity information for that customer. All of these concepts you can pull together and relate in a single graph, which then gives you incredible analytical power. Here's another type of scenario. So this is a little bit more operational. So here, the question on the table is, what is my procurement process look like? And the main entity here is a store location. And so this store, so imagine it is like a grocery store, for example, has a whole product supply chain. So they're basically sourcing product, perishables and non-perishables from a variety of distributors. Those are being provided to the store. They're getting invoiced for those, et cetera. For example, the perishables and the non-perishables might be being generated in specific lots. They all have SKUs, so maybe I have some tracking and traceability that I want to be able to impose on that data. Every one of my invoices has detailed line items. And then I have a whole bunch of service providers who are doing things like cleaning the store or doing the landscaping, et cetera. And all of these business entities, whether they're a supplier or a service provider, are operating under a set of contracts. Those contracts are with entities. Those entities that roll up to maybe parent entities. And then if I'm the chief procurement officer, I can look at a graph like this and I can say, how much am I spending through this network of entities? And could I do a consolidation and get better pricing leverage? And the point here is that with a graph like this, in a single data fabric, you can traverse from a master services agreement all the way down to the individual line items in an invoice. And so you have a very wide span of hierarchy, plus a bunch of transactional data that you can use analytically. Here's another type of graph. So this is master data management in B2B. And so the concept here is that my customer in a B2B scenario is an account. It's another company, right? And the perennial problem with B2B data is I need to know what contacts I can go talk to in that account. And in a large enterprise, that can be a difficult problem to manage. One of the things that you can do in a graph is that you can actually use the graph to compute a best or golden record from a variety of different data sources. And so then the idea here is that for every one of the contacts that I have, I can explode their contact information into a phone, an email, a physical address. And I can use the graph to understand the data lineage. So what source did this phone number come from? So was it a phone number that was on an original contract from 3 years ago? Or was it a phone number that was provided to me in an in-person event that we had last week? Right? Two totally different sources for a phone number. And you could basically create a rule that says, you know what, I'm going to give more authority to the phone number that I saw last week. Right? But now for a physical address, I might do the opposite. I might say, you know what, we're going to use the physical address that's on a contract or that's on that's a ship-to destination, rather than a physical address that I got, you know, off of you know, some form associated with a webinar. Right? And so what you can do is you can take all of those sources, you can trace the individual contact core data elements back to those sources. You can put some rules on how much authority you want to ascribe to each of those sources, and then you can compute a probability of accuracy and hang that probability on the relationship. And so now when I query my contact, not only am I querying for the details of the contact, but I can actually write my queries such that I can say, give me the highest probability phone number, give me the highest probability physical address and email. And so then you can basically have a very dynamic master data management approach that recognizes the provenance of all of the individual details. All right, so just to finish up this point, so you're still in laptop mode, you've got your data design together, and so you want to think about things like what are the breakthrough queries? There's opportunities to apply advanced analytics. There's some really nice algorithms that ship with Neo4j. And you know, you want to be use case specific. Feel free. There's projects you can go out onto GitHub and clone, and you can see how full stacks interact with Neo4j. You can use, there's a nice new interface called GraphQL, which is a new type of API. And the main thing is, you know, you want to focus on what is the value that you're being able to drive by putting the data in the graph. So now we know we can make, you know, now that we know this, we can make better decisions. We can now do these kinds of things for our customers. We can get these new kinds of experiences off the ground. At this stage, you'll begin to think about, all right, how do I scale it? And how do I actually expose my graph design to a totality of data? And this is the point when you start thinking about a cloud pilot. A lot of our customers like to do pilots in clouds, but you can also do it on-prem. And all of the cloud platforms have marketplace images or AMIs, where you can basically, with a few clicks, install a Neo4j server, single server, or even a cluster. And generally speaking, what you want to do is set up those servers so that they have attached drives. So you put your data on the attached drive, and then that way you can scale up or down your compute depending on how big your graph gets. And if you're talking about sizing your machines, generally speaking, rule of thumb, you'll need a VM that's about 50% of the size of the equivalent SQL database on disk. Python is very handy. There's a high-speed loader for slamming in all of your initial data. And then usually at this point, you'll start thinking about, you know, what kind of data cleansing you need. And if you get stuck on this stage, you can always reach out to your friendly system integrator, like my team at EY, or Neo4j, which has a very strong services offering as well. And you know, we can help you get over any difficulties you might have. As you approach your cloud pilot, I want to share with you the model that we use. And so the idea here is that you want to accelerate to discrete end user experiences. So as much as you might be interested in data and the inner workings of different types of databases and data management, your management doesn't really care how you do that. What they really care about is how are you going to help the company drive more revenue, drive better customer engagement, or be more efficient. That's basically it, right? And so as you think about your pilot, you want to think about, okay, so I've got this great data environment. Now what can I illuminate with that? What are the new use cases that I can drive? And so my general recommendation here is begin with, the minimum viable set of data domains, 2-3 data domains that are important. Put Neo4j on top of those data domains. Figure out what is the minimum amount of middleware you need to build, and then take it all the way out to the edge. So build a new website, build a new widget that can be deployed on the website, build a new suite of BI reports that show the power of connected data. And if you don't do this part, you run a strong risk of having a very interesting graph POC that just gets put on the shelf, right? And so, your job is to basically work with your business stakeholders and figure out what is going to be this new experience that will show the value of connected data, whether it's deeper analytics, faster performance, et cetera. Once you've got that done, it's actually usually pretty easy to add additional experiences, and then you can circle back around and begin to add new data domains. What you don't want to do is go down that boil the ocean approach where you say, we're going to take everything that's in our data warehouse, we're going to build some massive enterprise data model, we're going to dump all that into the graph, and then we're going to go looking for use cases. That's a recipe for failure. All right, so here's, I'll build these out really quickly. Here's some example architectures. These are pointing a little bit towards sales and marketing use cases. This is Azure. And the theme here is that you're putting Neo4j on top of a data lake and maybe some of the other polyglot persistence databases that we talked about earlier. Usually, these environments are surrounded by a set of additional value-added services that ship with the platform. And then usually you're going to be, you've got some kind of execution layer, whether that's a website or your data science team that is connecting to the graph through either drivers or APIs. So this is the Azure example. Here's the similar one for AWS. Okay, and then this is just to get you thinking about, depending on what cloud you might use. I'll point out Kettle has a Neo4j plugin that allows you to set up ETL data pipelines that can write directly to Neo4j. Neo4j also has connectors to systems like Snowflake through JDBC or DBC, and also has connectors into things like Couchbase and MongoDB, right? So you have a lot of flexibility. All of your applications, Neo4j supports drivers for .NET, Java, JavaScript, and Python. And then there's a bunch of community drivers as well. All right, so as you begin to build your bigger graph, this is a peek at what you can do with the Neo4j loader. So there's a high-speed loader, and generally what you'll do is you'll take your data out of your data lake. You'll create what are known as graph form tables, so deep tables of nodes, deep tables of mapped relationships between those nodes. So think of like maybe just the primary and foreign keys that relate your data. You'll zip those, you'll export those files as CSVs and zip them up. And then you can load those compressed files. And this is an example from a couple years ago. So this graph had on initial load 458 million nodes, 2.2 billion relationships, and 9 billion properties. And it loaded that in an hour and a half. So very fast, with a lot of data. So I also want to walk you through a quick example from oil and gas that brings to life a little bit of this kind of stack. So here, there's an open source data set out there that's called the Volve Field data set. And what it consists of is about 10 years of data that was pulled from an oil field in the North Sea, and it has exploration data and production data in it. And in the oil and gas industry, probably 95% of the data that's used is actually unstructured data. And so it's a great example to show how you can use Neo4j to do data unification. And so in this example, we're using Azure, Couchbase, Neo4j, and Power BI. And so here's the basic data flow. And what I want you to take away from this is the degree of compression you get using a metadata management approach. So we start off with about 5 terabytes of data. All of the semi-structured data, there's lots of XMLs that are coming off of these monitoring applications, et cetera. Those are all converted into JSONs. There's a bunch of reports that are being generated, also presented in XML. Those are also converted into documents in Couchbase. And so then Couchbase becomes the document repository. And then metadata and selected commentary is then pushed into Neo4j along with all the structured data and along with every single pointer to every single blob that is sitting in Azure. And all of that data is then pulled together in the graph. And so what you're looking at here is essentially a mixed-use graph where it's got some structured data. It has pointers and extracts from the semi-structured data, and it has pointers to all of the unstructured data. And so here, in a relatively small graph, this graph is about 1 gigabyte in size, we actually have real-time access to 5 terabytes of data. And this is just an example of some of the analytics that we can drive. So in the world of oil and gas, when something falls down the hole and you're doing drilling, that's called, that results in a phase of exploration called fishing, where you're trying to pull that broken bit up out of that hole that's a mile deep or so. And that's a real bad place to be because you're wasting a lot of money and everything is stopped until that bit of broken equipment is fished out of the hole. And so, of course, the obvious question is who was operating the drill rig when the thing fell down the hole, right? And so here's an example Neo4j query off of this database. And so we can basically pull up every single instance out of this 5 terabyte of data where time was lost due to fishing. We can map that back to the well that it occurred on. We can map it back to a set of reports and ultimately the contractor that was on duty while that was occurring. And then you can have a different kind of conversation with that contractor. So anyway, some screenshots. So this is Azure's blob store. This is typical data, so this is a seismic profile. And so you can't really do anything with this data except pull the file, and then it has to be visualized by some specialized application. But in Neo4j, we can at least find it, access it, search it, and present it. This is Couchbase using full text search. And so here we're searching for injuries. And then this is a GraphQL demo where we're using GraphQL on top of Neo4j. And this is a React page, and there's an Apollo driver that allows you to access data through the GraphQL API. And here we're running full text search. And if I wanted to, I could click on any one of those little blue clouds, and I could pull up the raw PDF. So again, that's an application where we're accessing this 5 terabytes of data. And then this is a little bit on how GraphQL works. So GraphQL is a structured API, and it works on a slightly different premise. So essentially, you're posting a graph type query, and then the Neo4j GraphQL driver and API is basically converting that into Cypher and then handing back the result. And so this is essentially a post request, and then as such, you can actually integrate it directly into tools like Power BI. And so anyway, so as you think about broadening your view around analytics and really leveraging Neo4j, so recognize that you can use Neo4j not only for direct management of data, but indirect management of data. And if you construct your modern data management stack so you have some of these other fit-for-purpose capabilities, you can use Neo4j to knit all of that together. And I think that's exceptionally powerful. So finally, as you go to production, all the regular IT stuff kicks in, right? So you have to think about your best practices, your security model. You can integrate Neo4j, with Active Directory groups through LDAP or Kerberos. You'll typically want some kind of a set of environments where you have, dev, test stage, and production clusters. You want to be able to have scripted deployments using your favorite DevOps package like Jenkins or Ansible, so that you can have consistent deployments, et cetera, et cetera. One of the things I'll point out is that you want to think about monitoring your graph, so you understand the kinds of queries that are hitting your graph, and then maybe periodically addressing the structure of the graph to see if it's really optimized to handle those queries. And I made that comment earlier. And then finally, leverage that iframe model. So once you're in production on a set of use cases, now you can then go back to the business and say, look, we stood up this new experience. It's working really well, and now we have an opportunity to see if we can drive additional business value by adding new use cases. This is a screenshot of an application that has been in production now for almost a year. It's Royal Caribbean, and so if you go download the Royal Caribbean app, we have a recommendation engine that provides suggested activities for passengers. And so this is just another form factor, so you can push out to your mobile devices, not just websites and so forth. So finally, I want to touch on these key conversations. So as you go into your thinking about how you're going to stand up Graph at your company, so figure out what problems is the Graph going to solve. What questions can we now ask and answer of the graph that we weren't able to before? What kind of data do we need to connect? What are we trying to do with the new experience? What's the feedback from the business on these new experiences? And so think about it as an agile, iterative conversation with your business. All right. Just to give you a sense of timing, we've done lots and lots of these graphs deployments in a variety of sectors. The thing that I want to call out here is that you should have the expectation of being able to build quite large graphs in a relatively short time frame. And by short time frame, I mean getting to like a working prototype using real data. And typically, we're able with one of those small teams to get a working graph together in somewhere between 12 to 16 weeks. This is a very fast process. It's way faster than building a data warehouse. All right, and that is the end of my talk. If you have any questions, feel free to ask.